So, good morning to everyone, and we are continuing with our lecture where we had stopped regarding microwave devices. So, please write your name along with your roll numbers, everyone. I hope you're doing that in the chat box, and now I'm going to start off with the session. So we have previously done what are the following components, that is E-plane, H-plane, magic T, and rat race. So I hope you remember rat race very well. Rat race T was where we stopped last time. So we have done the S matrix of the E-plane T, we have done it for the H-plane T, we have done it for magic T, and we have done it for the rat race T. So that is where we stopped. We also have something called coaxial connectors, which are connected to other, cables. So these are just to show you what kind of, coaxial connectors are used under microwave frequency. This is what is called as a rectangular waveguide, which is the main, you could say that all the components basically are nothing but rectangular waveguides. Like many of you all did practicals yesterday of microwave bench. So you saw the waveguide, different components along the line of the microwave bench where this particular structure is very, very common. So you have seen this as well. Today, I'm going to direct your attention to the directional coupler. So I want you to take this diagram down in your notebook of a directional coupler, because we're going to derive the S matrix. I will ask one student to give me the final result. So please make the diagram for the directional coupler. Please make the diagram for the directional coupler. So directional coupler also we have to study the S matrix. It's a 4-port device. It has what we call as a primary waveguide and the secondary waveguide. So we have port 1 and port 2, which is called as the primary waveguide, and port 3 and port 4, which is called as the secondary waveguide. So kindly take down the diagram for the directional coupler. I hope all those who entered have mentioned their name and their roll number in the chat box. Give me a thumbs up if you have completed drawing the diagram. I just want the diagram in your notebook first. Quickly the diagram. Okay, so Jacob has finished drawing the diagram. Give me a thumbs up quickly, everybody, to as you finish the diagram. I will ask the attendance 3 times in this session, 3 times. And if it comes 3 times, then the attendance is granted. So all of you have the diagram with you? So Akhil is giving me a thumbs up saying that he has finished drawing. Others complete the diagram quickly. Ashirwad has also finished. Okay, Shruti is also done. So I hope everyone has a diagram. So basically, the directional coupler is nothing but a 4-port device. So they are designed basically to, so you can see that this is a 4-port device here. This is your port 1, this is your port 2, this is your port 3, and this is your port 4. So they are basically designed to measure incident. So there will be incident or the reflected powers. They are also used for, SWR measurement to provide signal path to the receiver. So I'm just writing certain, things that you should know. I will write PI. That is the power that is incident at port 1. Power that is incident at port 1 will be called as PI. Then we have PB. Can anyone think of what is PB? So PB is nothing but the backward power. So what is PB? It is nothing but the backward power. This is the backward power, and PI is nothing but the incident power. So this we have the S matrix to calculate. So first we'll understand it. So what is PI? PI is nothing but the incident power. What is PB? It is nothing but the backward power. So is this arrow correct, or should I draw it in a different way? Is this arrow correct? Yes or no? Are you there, guys? So this arrow should be in this direction. So this is your backward power. Similarly, like that, we also have the forward power, which is in port 4. So here you have to draw PF. PF stands for the forward power. And then we have something that is nothing but one more power, that is at port 4. So we have PI, we have PF. You can also call it as the received power. So we have the received power, that is PR. That is PR. So we have 4 things here. Received power, forward power, backward power, and incident power. So if the wave is incident from port 1, everyone's attention here. If the wave is incident at port 1, it couples its power to ports 2 and 4 and not to port 3. I repeat once again. So you can see odd numbers on the left hand side, that is 1 and 3. And you can see even numbers, that is 2 and 4. So you have even numbers on the right hand side, that is 2 and 4, and you have odd numbers at 1 and 3 on the left hand side. So if the wave is incident from port 1, it couples power to 2 and 4, but it will not couple power to port 3. And if the wave is incident at port 3, it will couple power to 2 and 4, and it will not happen at port 1. That means 1 and 3 are isolated, 2 and 4 are isolated. Similarly, if I send anything from port 2, then it will couple itself to 1 and 3, and it will not get coupled to 4. So, you have to understand how this entire structure works. So if I'm sending from 1, it goes straight to 2. It will also give some power to 4, but it will not have any power at port 3. So this is the basic understanding of the 4-port device, which is called as a directional coupler. So directional couplers are basically designed to measure incident or reflected powers, SWR, and to provide a signal path to the receiver. I repeat, directional couplers are designed to measure incident or reflected powers, SWR, and to provide a signal path to the receiver. So let us see some very important terms that are important with respect to the directional coupler. We have already defined what is PI, we have defined what is PR, what is PF, and what is PB. PI is incident power, PB is backward power, PR is received power, and PF is forward power. So let us see what is the characteristics of this. What are the things that you should remember about the directional coupler? So in the directional coupler, the first term that I would like all of you to remember is called as the coupling factor. It's called as the coupling factor. So what is the coupling factor? It is given as 10 log to the base of 10 Pi upon Pf. And this is given in dB. I repeat once again, what is coupling factor? It is 10 log to the base of 10 Pi upon Pf into dB. So it's a ratio of the incident power to the forward power measured in dB. So coupling factor is a very, very important term regarding directional couplers. It is a ratio of the incident power to the forward power. So basically, it is a measure of how much of the incident power is being sampled. How much of the incident power is being sampled. The second term that we must know here is called directivity. So these terms are very, very important with regard to the directional coupler. Directivity is the formula 10 log to the base of 10 Pf upon Pb in dB. So here you can see, you can define it. It is a ratio of the forward power to the backward power. So it is a measure of how well the this directional coupler distinguishes between PF and PB, that how much of it is forward and how much of it is backward. So this coupling factor and directivity are two terms that I believe you should know. Now we are moving to understanding the S matrix as always for anything. So we are doing the S matrix of this directional coupler. So let us check on the S matrix of this directional coupler. So let's start off. I'm starting off with the first point. I hope you're with me. I hope you're writing with me. Let's start off. Are you all ready? Akhil has informed me that there is a new head now to the class. Is it decided, Akhil? So let us see. Okay, he's saying it's not yet decided. Okay, fine. So we are starting off with the S matrix, and I hope everyone is following the same. Let's start off with the first point of the S matrix. First of all, DC, that is the directional coupler. So I will write it as DC, is a 4-port device. So it's a 4-port device. And as it is a 4-port device, everyone knows the matrix is going to be, so the S matrix is a 4 into 4 matrix. It's a 4 into 4 matrix, right? Now with all the diagonal elements, that means I'm making my first condition here, they are 0. What is the meaning of this? Anybody in the chat box? What is the meaning when I put 0? When I put S11, S22, S33, S44, 0, what does it mean? What does it mean? Perfectly matched, says Vishnu. Yes. So S11, S22, S33, S44 are perfectly matched. So there is no back reflection from them. Basically, if you give it from the same input. So they are perfectly matched. So that's the first point. Moreover, you must understand that all these devices are symmetric. We have done the conditions for symmetricity. So our second point over here will be, that the device is symmetric. So you know, when I say that Sij is equal to Sji, Sij is equal to Sji. So I'm going to kind of write the S matrix as always. Going to write the S matrix as always. So basically it's a 4 into 4 matrix this time. And all our diagonal elements are just 0. So I'm just writing it initially because this is slightly different than what we used to do. So we are just putting it. We can write 2, 1 as 1, 2 also. This is 0. Please check if this is understood. So this is going to be our S matrix. Because 2, 1 is equal to 1, 2. So I've already substituted 3, 1 is equal to 1, 3. 3, 2 is equal to 2, 3. So I have not written it separately because I understand that we have done a long way of S matrix. And so it is understood that I'm using the symmetry property here. So the S matrix will look something like this. I hope everyone has this S matrix now with them. Now, what did we say? That if you remember, we said there is no coupling between 1 and 3. That means if I send power from 1, it does not come out of 3, isn't it? There is no coupling between 1 and 3, and there is no coupling between which other 2 ports there is no coupling. If I send from 1, it doesn't come out of 3. Similarly, which 2 other ports there is no coupling? Please answer in the chat box quickly. 1 and 3, there is no coupling. Which other 2 ports there is no coupling? Yes, Ajay. Very good. Ajay says 2 and 4 also there is no coupling. So neither 1 and 3 nor 2 and 4. So both of them don't have coupling. That means that which terms here can I say they are 0? Anyone? Which terms here, which coefficients here will become 0? If there is no coupling between 1 and 3 and there is no coupling between 2 and 4, which coefficients in this S matrix is going to become 0? Who will answer? Quickly. Which one? Which term here, which coefficient here can become 0? How many coefficients you can see will become 0? So you will have 1, 3, which is 0. What else can become 0? 2 and 4 can become 0 because there is no coupling. Any other? There is 1, 3 here also. There is 2, 4 here also. So wherever there is a combination of 1, 3 and 2, 4, they will all become 0. So this entire S matrix is now going to change. And it is going to look like this is 0. This is S12. This is going to be 0. This is going to be S14. This is going to be S12. This is again 0. This is S23. This is 0. This is 0. This is going to be S23. This is going to be 0. This is S34. This is going to be S14. This is going to be 0. This is going to be S34. And this is going to be 0. So this is how we are going to get the S matrix, and this is how it is going to look. So this is how the S matrix is going to look for us. Now, as always, we are going to use the unitary property. Everyone knows the unitary property, that is S into S conjugate is equal to I, the unitary matrix. So I'm not writing that whole thing again. It will be S into S conjugate is equal to I. So R1, C1, I will get one equation. I will get an equation like S12 into S12 conjugate plus S14 into S14 conjugate. You can check if you're getting the same thing. Then we will do for R2C2. So you will get S12 into S12 conjugate plus S23 into S23 conjugate is equal to 1. And similarly, you will get for R3C3, that is S23 into S23 conjugate plus S34 into S34 conjugate is equal to 1. And similarly, we'll get for R4C4, that is S14 into S41 or 14 conjugate plus S34 into S34 conjugate is equal to 1. I'm also taking one more row, that is I'm taking R1C3. So I'm doing S12 into S23 conjugate plus S14 into S34 conjugate is equal to 0. So we have taken 4 equations here. I hope you mark them. 1, 2, 3, 4, and yes, one more, that is the 5th equation. So we have 5 equations with us. R1C1, R2C2, R3C3, R4C4, and R1C3. So we have 5 equations with us. And using these equations, we will remove some conclusions. So quickly write down the equations, everyone. And give me a thumbs up in the chat box when you're done. Quickly. From equations 1 and 2, what could be your conclusion? From equations 1 and 2, what could be your conclusion? And what could be your conclusion from equation number 2 and 3? I want some relation. I want some relation. So anybody who could answer that question? You can unmute yourself and answer if you know. I want, what is the relation I can get from 1 and 2, and what is the relation I can get from 2 and 3? Anybody? Please say your name and your roll number. Anyone from 1 and 2 and 2 and 3? Any conclusion from 1 and 2 and 2 and 3? Aparna, Srividya, and Unnimaya, your sound system is not connected to the system, so will not be granted attendance. I would like to know what is the conclusion from equation 1 and 2 and 2 and 3. Vishnu, can you answer that question? Okay, so I can see Akhil and Nishin answering there. S14 is S23. Okay, brilliant boys there. Vishnu and Nishin and Akhil. Yes, so the conclusion is absolutely correct. So they have given us the conclusion from equations 1, 2, 2, and 3. So what is the conclusion? I can say that, So I think that is point number 5 in your books. In point number 5, I can say that mod of S14 is equal to S23. And I can also get the S12 is equal to S34 from both the equations. So this is the conclusion that I'm getting. Audio is connected. Okay, Unimaya. Okay, you have 2 devices working. Okay, fine. So I hope the others too also reply to the question that I asked. So Unimaya's confirmation is there. Now we are going ahead. So we have 2 conclusions, that is S14 is equal to S23 and S12 is equal to S34. I hope everyone has written this down now, because it's slightly different than what we used to do before with ones and zeros. So it is slightly different. So let us see. So what we are going to do here is, you can write like this: by choosing reference plane of port 1, reference plane of port 1 with respect to that of port 2, and reference plane of port 3 with respect to port 4. What we are going to do is, we're just going to assume something which is very important. We are going to call it as alpha. So this S12 is equal to S34, we are going to call alpha, where alpha we are going to call it as a positive real number. So this is something different in case of a directional coupler derivation. Positive real number. Now from the last equation, that is from the 5th one that we have done for S parameters. So here you are just assuming that S12 and S34 are nothing but alpha. And from the last equation, I hope all of you have the last equation with you. That is the 5th one. So from the 5th equation, I'm making a small, I hope all of you have the 5th equation. So it was S12 into S23 conjugate plus S14 into S34 conjugate is equal to 0, I think, right? Now, what do I do here? Anybody? Can I take something out? Can I modify it some way? If you can think of something. Three, 4 is nothing but 1, 2. Just now I have written here 3, 4, whatever you have got is equal to 1, 2 from this equation. Yes or no? So I'm going to substitute that here. So I'm going to write it as, I can take basically S12 common. I can say now S23 conjugate plus S14 is equal to 0. That means I took S12 common in both cases. That means this now S12 I have taken as alpha. That means this is alpha times of S23 conjugate plus S14 is equal to 0. Now this alpha is a positive real number. So alpha is not equal to 0. That means S23 plus S14 can be equal to 0. So I'm going to assume that, and I'm going to say, so I hope you've finished till here. I've put alpha instead of S12 here. And so I will get, this is point number 7 going on. So I will get that as alpha is not equal to 0, that means S23 conjugate plus S14 is equal to 0. But you know that S14 is nothing but S23. So we'll write S23 conjugate plus S23 is equal to 0. That means basically what we are doing here is, we are saying that let this S23 be equal to J beta, then this S23 conjugate is equal to minus J beta. Right? So now again, selecting the reference plane of port 4 with respect to port 1, right? So we are making nothing but S14 is real. So in point number 8, I'm writing S23 is equal to minus S23 conjugate is equal to S14 is equal to J beta. So I'm not doing anything great. I'm just substituting everything back into the S matrix. So I will get, if you go back and check your S matrix, you will get something like this. So you will see that we have just replaced it with alpha and beta, J beta. So this will be alpha, this will be 0, this will be J beta, this will be 0, this is 0, this is J beta, this is 0, this is alpha, this is J beta, this is 0, this is alpha and 0. This is the S matrix of the directional coupler, where I can say that alpha square plus beta square is equal to 1. This is basically for the conservation of energy, and this alpha in microwave terms is called as the transmission factor. It is called as the transmission factor, and beta is called as the coupling factor. So this is the derivation that is for the directional coupler that they are expecting in the examination. Also, one more thing in the note you can mention is that the coupling, in case of a directional coupler, the coupling of an ideal coupler is given as C is equal to minus 20 log to the base of beta. That is in dB we are saying. And the directivity of the directional coupler is 20 log of in dB. And S13 is basically 0 actually for an ideal coupler. Just a small understanding of it is just a note. It's not very, very important, but okay. You need to know this, that's all. So this was about the directional coupler, at least till the S matrix has everyone completed. Till here, I want everything completed. That is alpha, beta, and so on. Have you completed the S matrix? This is the S matrix of a directional coupler. So we have seen E plane, we have seen H plane, we have seen magic T. Now we are also seeing the directional coupler. So at least till here, alpha, beta, it should be completed. Have you completed, everyone? So even if you don't write these part, it's okay in the notebook. I want in the notebook at least till this is something extra. So this is okay if it is not included in the notes. It should not confuse you later. I'm not deriving it basically. Everyone has completed till the S matrix. Okay, so Lidvya, Shruti, Ashirvad have completed, giving me thumbs up. Or Gina, Hima, they have also completed. Okay, so we'll move ahead. So that was the directional coupler. There is something called as a two-hole directional coupler. So sometimes they ask with respect to a two-hole directional coupler also. So as you can see here, what is the modification is that you can see that unlike the other time, they have a single waveguide which is going through, that is port 1 and port 2, and they have some side port. So that is a two-hole directional coupler. So basically a two-hole directional coupler is to meet the ideal requirement of the directional coupler, which is to avoid the back power. So some of the power while traveling between port 1 and 2 will escape through these small holes here. So if you can see here, they will escape from these two holes. Now, what you are seeing here, this gap, this hole that you can see here is at a distance of lambda g by 4. So you need not take this down. Just listen. I will obviously pass the PowerPoint so you can read it. And one more point about it is that the magnitude of the power depends on the dimension of these holes, right? So how much power is getting leaked out or how much is in the forward direction all depends on the dimension. So you must always remember, whenever we are designing anything in the microwave lab, we are studying something. So the dimensions of all these, taking from the rectangular waveguide to circular waveguide to the magic T to the directional coupler, the dimension is to be given a lot of importance or significance. So because the directive nature of each of the component will depend upon these dimensions. So just to know that the two-hole directional coupler. Okay, so this is just to tell you what looks in the textbook will look like. This kind of a diagram is a two-hole directional coupler in LiO. So I have written about it. You can read it. It is not much asked, but you can definitely read about the coupler. Then we have something called as a phase shifter, which I wanted all of you to know, because I'm going to give you some work for Monday. One single question I'm going to give, and I have to explain what is a phase shifter. So because I want all of you to think regarding this matter. So what is a phase shifter? As the name suggests, it gives you a 180-degree phase shift. So a phase shifter produces an adjustable change in the phase angle. So I can have a 180-degree phase shift of my wave using what is called as a phase shifter. So a phase shifter is a ferrite device. So ferrite material devices are nothing but non-conductive materials are used. So we have phase shifter there, we have attenuator there, we have isolator there, and we have circulator there, which are nothing but called as ferrite devices. So phase shifter is something that gives the wave a 180-degree phase shift. Okay. So I'm not going to read the theory now here. I have written it down. You can read this theory. Let's come to the circulator. So let's understand what is a circulator. Very interesting part of the chapter, just like how you had done rat race. Now, looking at this diagram, can anybody think that what must be happening here? If I send the wave from port 1, look at the circulator, everyone, and anybody who can, you can unmute yourself, and if you can tell me, anyone who would like to look at the diagram and explain that how does this work? The diagram itself tells you everything. Ashwati, would you like to answer? Ashwati Ashok Kumar. Yes.
Yes, miss.
Yeah, can you answer? Like looking at the diagram, that if I send a wave or power from port 1, where will it go?
It will go to port 2.
Yeah, excellent. So it goes to port 2. Will it go to port 3 and 4?
No.
Yeah, thank you, Ashwati. So port 1, whatever you take, goes to port 2, will not go to port 3 and 4. The diagram is self-explanatory. If I send a power from 2, it will go to 3. If I send power from 3, it will go to 4. If I send from 4, it will go to 1. That's why it's called circulator. So if I send from 1, it's only going to 2, right? So interesting kind of a device. While rat race, we had, if you remember, I had used a term and the whole class was laughing. It's called ajubaju. I said left and right, right? So you have to remember what is the difference between the hybrid ring, that is the rat race device, to the 4-port circulator. So this is the 4-port circulator. Can you please take down the diagram quickly? Circulator is also a ferrite device. And the circulator's functioning is very, very simple. It's a 4-port microwave device. So it has a very peculiar property, isn't it? That each terminal is connected to the next in the clockwise terminal. So port 1 is connected to port 2 only, and port 2 is connected to port 3 only, port 3 is connected to port 4 only. So there is no restriction, remember, on the number of ports. Okay, so 4 ports are the one which are commonly used, but there is no restriction. We can use n number of ports. And please remember, they are useful in parametric amplifiers. They are used in tunnel diode amplifiers, and they are used in radars. So this is something that I expect you to remember. So what does a phase shifter do? A phase shifter gives you a 180-degree phase shift, and a circulator gives you nothing but a cyclic movement, right? Port 1, 2, 3, 4, cyclic movement. So you have to remember a circulator, and you have to remember the phase shifter. Magic T you already know. So I have written here all the theory about it, that all the 4 ports are matched and transmission of the power takes place in the cyclic order only. They are lossless, and they work on the principle of what we call as a Faraday's rotation. So there is a ferrite rod inside, which has been, so this is the construction inside the, we will go to the working of it, but this is how the circulator looks inside. So what you're looking at is just this, the first diagram here, but in the actual diagram, so there is a rectangular waveguide, some portion of it, there is a circular, that means inside it is circle. And here again, we have a projection. So what looks very simple here in this diagram as 1, 2, 3, 4, inside the diagram, we have a ferrite material, which is giving a 45-degree phase shift inside for the power that is coming in. So this is a very, very important diagram. Again, I have taken it from LIO. So you must read LIO always. This is another way of representing the same circulator. So the circulator diagram is again given. See, it looks so simple when you look at it the first time, isn't it? But inside the circulator, the way the wave propagates is a very important factor. So this is one of the diagrams that is related again to the circulator. So we will see how the right now I'm just telling you this much only, that they are going from which port to which port. So looking at the 4-port circulator, I just want you to take down the S matrix. So the S matrix of a circulator is what I want all of you. So you can see they're perfectly matched. So diagonal elements I have taken here as completely 0. So diagonal elements you can see are here, the diagonal elements, that is S11, S22, S33 and S44 are 0. So that you have to see very clearly. 1, 2, 1, 3, 1, 4, we are keeping it as it is. And the final, that is the S matrix of the circulator, will look something like this, the final S matrix. So you don't have the derivation for it, but you need to remember the S matrix. So I want all of you to remember this one and this one. Please take it down and see whether you have understood. When I say port 1 gets linked to port 2 only, 2 is coupled to 3 only, and 3 is coupled to 4 only, and 4 is coupled to 1 only. So that is the S matrix. We don't have the derivation for circulator, so that's why you will take the S matrix directly now. Have you completed, everyone? I just want the S matrix with all of you for the circulator. So we have derived for directional coupler today. We know what a circulator is. So I just want the S matrix completed quickly. This is for a circulator. Completed, class? Okay. So now, so what is an, now from the circulator, we will also look at isolator. So those who were in the practical yesterday have already done practicals on the reflex klystron. So the first, just after the source, what you see is nothing but an isolator. So isolator is basically a non-reciprocal, transmission device. So what does isolator do? As you can see, the name itself suggests that it will only go in the forward direction. It will not go in any backward direction. So whatever wave, it's a two-port device. So whatever you send here will go straight out. It will not give any kind of back reflection. So it's very, very important because it basically is telling you that a very ideal isolator will basically absorb all the power and it will propagate in only one direction. And there will be a lossless kind of transmission in the opposite direction. So sometimes it is also called as a uniline. So when they say uniline, basically they are talking about the isolator. So what isolators are generally used for? Just after the generators they are kept, just after the sources they are kept. So they are basically to improve the frequency stability of the microwave generators, such as klystrons and magnetrons. So klystron we will be studying in detail in the lab. You will be taking the characteristics out. Magnetrons, as I had always told you, it is there sitting in your house in the microwave oven, generating the microwave frequency of 2.45 gigahertz. So that is what an isolator does. So similarly, we have something called as a gyrator. So a gyrator again is a two-port device, and it has a 90-degree twist. If you can see this particular diagram, it has a 90-degree twist compared to the construction of the circulator and so on. So if you look at the ferrite device here, which I was talking about, there is again a 45, there is a ferrite device which allows that 45-degree variation in angle of the wave. Similarly, even a gyrator will have a certain property, but it has a twist which is called as a 90-degree twist. So this one I have to explain in detail. I'm just introducing the components today to you. And we have something called attenuators. So what would we are looking at the new words today? That is attenuator, we have gyrator, we have circulator. So these are nothing but all ferrite devices. They work on the Faraday's law of rotation. So attenuators again are passive devices which are used to control the power levels in a microwave system. So they by partially absorbing the transmitted signal wave or whatever input you are giving to the system. So there are fixed attenuators, there are variable attenuators. Fixed attenuators are used to lower the voltage, dissipate power, and to improve the impedance matching. So we must know that about attenuators as well. Okay, I'm not going into the working principle right now because I will need more time to explain this and we are already running out of time. So now quickly, I have the homework that I want on Monday. So I'm just going to display the homework. Can you write down the homework? You have to design a circulator using the passive components. Please take down the homework. I want you to construct, basically, I want you to, the homework is basically to construct a 4-port circulator. I want you to construct a 4-port circulator from more detail. Basically, I'm telling you what to do from magic teas and say a non-reciprocal phase shifter, or let's say you use a gyrator. So a gyrator basically gives a 180-degree phase shift in one direction. So remember, the gyrator is a non-reciprocal phase shifter. That means it will give you 180-degree phase shift only in one direction. So this is your homework for Monday. I want you to try construct a 4-port circulator from magic T and a gyrator, which is a non-reciprocal phase shifter. Please take down the diagram. Once again, I want the attendance in the chat box. Everyone. Once again, attendance in the chat box. All the students will give me attendance in the chat box. Write your name along with your roll number quickly. I am copying the numbers, so I want everybody's name and roll number in the chat box. Have you taken down the homework?